Okay, we are going to look at some word problems for quadratics. So on the left of my screen, you're going to see the little story and what an equation, and then we're going to answer a couple questions about that equation, and we're going to use Desmos to help us look at the graphs. So the first one says Jason jumped off of a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t is equal to negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. So basically what we're looking at is a function that talks about somebody, right, jumping off of a cliff. So if we are thinking about this situation and thinking about what we're doing, right, if this is a cliff and this is the water down here, then this person, right, is jumping from here. Right? There's a little person up here, and he is jumping into the water. Okay, so imagining that situation sometimes can help you. Okay, but also we're going to use the graph in Desmos over here. Right, I've already put the equation in. You can see that the graph ends up looking, you got to zoom out a little bit, right? It's kind of going to be pretty big because we're thinking about somebody jumping off a very high cliff. So again, if you spread your axes out a little bit, you can help this. Okay, we've looked at doing this before, but you can start your x-axis at 0 and end it at, 5, and then you can see a little bit better what the graph might look like. So when I did that, I basically have my starting point, right, where I'm jumping off from. And you jump, you go a little bit up, and then you come down, and very far down at the bottom, right, you're going to hit the water, right? This is probably pretty dangerous. So if I think about this, it says, how long did it take for Jason to reach his maximum height? So maximum, right, we are looking for the vertex. Now, the vertex point, right, was up here. Well, looking at Desmos, we can tell that that vertex point was at 0.5 and 484. Well, just like we know, the t is like my x, right? And so my x is this first number. If I thought about it as t, it equals time. And so x is still my time. And the other part, right, the h is the height. The h is the height, and that's my y. So these two numbers represent the time and the height. So basically what I'm saying is that this is the time it took me to get to that maximum height. So over here, how long did it take for him to get there? 0.5 seconds. Right? We're talking about time in seconds. It tells you right here. So then looking at the second, it says, what was the highest point that Jason reached? Well, that's coming from the same point. So we are again using the y part, right, to talk about the height. And so that 484, we just need to say that it represents feet because that is what it says in the problem. And then the last one is Jason is talking about when he finally hits the water. Okay, so think about that as the ground or the x-axis, right? So right here, I'm looking for one of my zeros. So one of my zeros, the positive one, is going to represent the time that it took me to get down to 0 level or the water. And so this number here, it says 6, 0. And again, the x is the time and the y is the height. So when I'm at 0 height, it took me 6 seconds to get there. So we can see that 6, 0 is that point. So 6 seconds is how long it took. So hopefully you're seeing that we're really just reading the situation and using the graph to help us. All right, so the second problem, I'm going to go through one more and then you guys can do the ones on the back. If a toy rocket is launched vertically, that means up, right, straight up, from the ground level with an initial velocity of 128 feet per second, and then its height, h, after t seconds is given by the equation h of t is equal to negative 16t squared plus 128t if air resistance is neglected. So we're not paying attention to the air resistance. So how long will it take for the rocket to return to the ground? So again, I'm thinking about a problem right here. I'm on the ground, I'm shooting the rocket up, it's coming back down. and I just need to know when it gets back down here. All right, so we're going to look at the equation used in this problem by clicking on the equation I already typed in here in Desmos, but you can do the same thing. So when I look at this, right, I'm here at 0, I'm shooting the rocket upward, it goes up, it goes this way, and then it comes back down. All right, so this point up here is 4, 256, okay, and this point here is 8, 0. So let's look at the questions. How long will it take for the rocket to return to the ground? The ground is here. So when I'm returning to the ground, that is the 8. And again, my x is like my t. In the problem, I used t, but in Desmos, I used x. So this means 8 seconds is how long it takes the rocket to come back down. And then after how many seconds will the rocket be 112 feet above the ground? All right, I need to find 112 feet above the ground. So again, when I'm in Desmos, right, I can use my table of values to find, right, when I would be at 112. Well, if I pulled up my table of values, you can see here that at 1 second, I am at 112 feet above the ground. And you can see that point right there, 112. So I saw in Desmos this point, right? And that means that I am thinking about 1 second after launch. How long will it take the rocket to reach its maximum height? Well, its maximum is the vertex. So the vertex up here, we already know that 256 feet is the vertex height, but we're looking for the time here because it says how long will it take. So if it says how long will it take, the number is 4, right, from that vertex. It's half of the time, right? If it takes it 4 seconds to get up, then it takes it another 4 seconds to come down, right? So 4 seconds and 4 seconds, right, gives me 8 seconds, the total travel time. And the last one, what is the maximum height? Well, we just said the vertex has a y value of 256. Well, that's my height, right? The x is the time and the y is the height. And so we are going to say 256, and then just make sure you use the right number here. It's talking about feet. So when I represent 256, don't just write the number. Tell me what that means, right? It could be meters, it could be feet, it could be miles, right? If we're talking about rockets. So in that case, it's feet, not feet, sorry. Feet, right? 256 feet. So as you do your practice, right, you have a couple of problems on the back. I just want you to try them out, okay? Use Desmos to get the answers, but you're interpreting the graph, okay? So looking at the graph to help you get the answers. Good luck.